Hello! In this video, we are going to prove the following theorem. The following are equivalent. Now, in proving that all three of these are equivalent, what we're going to do is we're going to prove if 1 is true, then 2 is true. If 2 is true, then 3 is true. And finally, if 3 is true, then 1 is true. This will tell us that if any one of these happens to be true, then all three of them must be true. Similarly, if one of them is false, then all of them must be false, right? All three are equivalent. So, now let's get into the proof. We'll start out by proving if 1 is true, then 2 is true. And to do so, suppose 1 is true. What does this mean? It means that there is at least one object out there where this statement is true. So we can instantiate some object, call it X, where this is true. And we can take this conjunction and break this up into two parts. We have that P of X is true, and we also have that this is true. Now, our goal is to show that 2 is true, which means we want to find some object which satisfies this statement. And our claim is that X is an object which will satisfy this statement. So we're going to take the X here to be X, and we're going to show that this is true. So since we're trying to prove a statement about every object, give me an arbitrary object. I'll call it Y. And from here, we want to show that P of Y is true if and only if Y is equal to X. Well, we're trying to prove a statement containing if and only if, so what we're going to do is we're going to prove if this is true, then this is true, and we're going to prove if this is true, then this is true. Let's first prove if this is true, then this is true. To do so, suppose P of Y. And from here, we want to show that Y is equal to X. Well, since this statement is true for every object, it must be true for our object Y. So if we take the Y here and substitute it for Y, we have that if P of Y is true, then Y is equal to X. Well, we know that P of Y is true, so we must conclude that Y is equal to X. So what we've shown here is, under the assumption that P of Y is true, we have that Y is equal to X. So we have shown that if this is true, then this is true. Now we're going to show if this is true, then this is true. So let's suppose Y is equal to X. From here, we want to show that P of Y is true. Well, we know that P of X is true, and since X is equal to Y, we can take the X here and substitute it for Y. So what we've shown here is if Y is equal to X, then P of Y. So we have shown if this is true, then this is true. So we've proven both directions. So we have proven the if and only if. And since Y was arbitrary, this means for all objects Y, this is true. And at this point, we have found an object which satisfies this statement. Namely, if we take X to be X, well then yeah, this is true, right? So we have proven that 2 is true. So at this point, we have shown if 1 is true, then 2 is true. Now we're going to show if 2 is true, then 3 is true. And to do so, suppose 2 is true. Well, this means that there is at least one object which satisfies this statement. So we can instantiate some object, call it X, where this is true. And at this point, we want to show that 3 is true, right? We want to show that this is true and this is true. Let's first show that there exists an object X such that P of X. So we need to find at least one object which satisfies this statement. Well, our claim is that we choose X to be X, and we will have that P of X is true. Well, since this statement works for every object, it must work for our object X. So if we take Y and substitute it for X, we get that P of Y if and only if X is equal to X. Well, we know that X is equal to X, so since this is true, we must have that this is true. So we have found an object which satisfies this statement. Namely, if we take x to be x, well, we have that p of x is true. So we have shown that this is true. Now we're going to show that this is true. And we're trying to prove the statement about every two objects. So give me any two objects. I'll call them y and z. And from here, we want to show if this is true, then this is true. So let's suppose that this is true. Well, we can break up this conjunction into two parts. We have that p of y is true, and we also have that p of z is true. But now, since this statement works for every object, it must work for our object y. So if we take y and substitute it for the y we have here, we have that p of y is true if and only if y is equal to x. And similarly, we can take the y here and substitute it for z, and we have that p of z is true if and only if z is equal to x. But since p of y is true, we have that this is true. And since this is true, we must have that this is true. Similarly, since p of z is true, we have that this is true, so we must have that this is true. So we see that y is equal to x and z is equal to x. So y and z are both equal to the same thing, which means y and z must be equal to each other. So what have we done here? Well, we gave ourselves two arbitrary objects, y and z, and we show that if p of y and p of z is true, then y is equal to z. Since y and z were arbitrary, this means we have shown that for all objects, y and z, if p of y and p of z is true, then y is equal to z. So we have shown that this is true. So we have shown that this is true and this is true. And that means we have shown that 3 is true. So we have shown that if 2 is true, then 3 is true. So at this point, we have shown if 1, then 2, if 2, then 3. So all that's left is to show that if 3, then 1. And to show if 3, then 1, let's suppose that 3 is true. Well then, let's break this conjunction up into two parts. Now, this means that there is at least one object which satisfies this statement, and we'll call that object x. So let's instantiate an object x which satisfies this statement. Now our goal is to show that 1 is true, which means we want to find at least one object which satisfies this statement. And our claim that one object which satisfies this statement is the x we have in our proof. So, taking x to be x, we're going to show that this is true. Well, we already know that p of x is true. That's what we have here. So all that's left is to show that this is true. So since we're trying to prove the statement about every object, give me an arbitrary object. I'll call it y. And from here, we want to show if p of y is true, then y is equal to x. So let's suppose that p of y is true. Since this is true for every two objects, it must be true for y and x. So if we take y to be the y we have here, and we take z to be the x we have here, well then we have if p of y and p of x, then y is equal to x. Well, we know that p of y and p of x are both true, so we must have that y is equal to x. So putting this together, we started with an arbitrary object y and show that if p of y is true, then y is equal to x. Since y was arbitrary, this means we have shown that for all objects y, if p of y, then y is equal to x. So we have that p of x is true, and this is true. So we have found an object x which satisfies this statement. Namely, if we take x to be the x we have in our proof, well then, we have that this is true. So there is at least one object which satisfies this statement. So we have shown that 1 is true. So if 3, then 1. And so we have proven if 1 is true, then 2 is true. If 2 is true, then 3 is true. And if 3 is true, then 1 is true. And as we said at the beginning, this tells us that all 3 are equivalent. And that's exactly what we wanted to prove. So this completes the proof. And so yeah, that's pretty much it for this video.